Okay, this video is going to be about the diatomic gases. We're going to talk about what they are, and then we're going to talk about what they would look like if we could actually zoom in and see the atoms and molecules that make stuff up. Okay, so there are about 100 elements on the periodic table. And of those 100 elements, 7 of them are the diatomic elements. These are the diatomic elements here, and at the end of the video, I'll teach you some memory tricks so that you can remember which of the elements are diatomic. But anyway, what makes the diatomic elements special is that we never find a single atom, just one atom, of any of these guys on its own. Okay? So you never find just an oxygen atom hanging out, or a nitrogen atom, or an iodine atom. Instead, these atoms always pair up. You always find 2 of them together, connected together, forming a molecule. Let me show you what I mean. I'm going to draw some diagrams, and I'm going to put this thing up here, abbreviations of all of the different diatomic elements, just so you can remember which elements are diatomic and which aren't. Okay, so let's take 2 things that have gas in them. Here is a tank of oxygen gas. I stole this from my grandmother's nursing home. I was like, hey grandma, can I borrow your oxygen tank for a minute? And then I went to a kid's birthday party and I stole a helium balloon from the clown. Okay, so here's what I want to do. I want to put on my superhero glasses that allow me to not only look through the shell of this tank, but let me zoom in trillions and trillions of times and actually see the atoms that make up this oxygen gas. Here is what I'm going to see. Here's my enlarged view. Now remember that oxygen gas is there's an O up here. This is one of the diatomic elements. So this is what I'm going to see. I'm going to see that the oxygen gas is made up of oxygen atoms. You know, that's not a big deal. But I'm going to see that all of the oxygen atoms in the gas are connected to each other in pairs, just like this. They're connected in pairs, forming molecules. On the other hand, let's look at helium. Helium is not one of the diatomic elements. And so if I put on my superhero magnifying glasses and look at the helium balloon, I'll also see atoms that make up the helium. But here, He, He, these atoms are individual. They're on their own because helium is not a diatomic gas. I should also point out that I'm talking about gases here. All of the diatomic elements are gases at room temperature. So we always usually talk about gases when we're talking about diatomic elements. Okay, diatomic elements pair up, non-diatomic elements don't. Here's also what's important about this though. The fact that these guys pair up influences how we write the name of oxygen gas. So if someone asks you to write the name of the chemical formula for oxygen gas, it's O2, because each piece of oxygen gas is 2 oxygen atoms connected together forming a molecule. So O2 for oxygen gas. But on the other hand, someone says, write the chemical formula for the gas, for the helium gas that's in the balloon, it's just He. It's not He2 or anything, it's just He. And that's because the helium atoms are by themselves, one at a time in helium. Just to give you 2 more examples, particularly of the writing of the chemical formulas here. I got a hydrogen balloon. You can also put hydrogen in a balloon. And then I've got a light bulb that has argon in it. Argon is a gas that's in light bulbs. And here is what the hydrogen would look like if I could zoom in on it. Look here that hydrogen is one of the diatomic elements, whereas argon, which is not a diatomic element, the atoms would be on their own. Going back to that idea of how we write the chemical formulas of stuff that's made up of diatomic elements, hydrogen, someone says write the chemical equation or the chemical symbol for hydrogen gas, it's H2, whereas argon is just Ar. So, whether or not something is diatomic influences how we write the name of the chemical. So, it's important to remember which of the elements are diatomic and which aren't. So how can you do that? There are a couple ways. Here's what I like to do. I like to take the symbol of each of the elements and write it out like it's a letter or group of letters in a word. And when I do it in this order, I come up with a word that sounds sort of like Brinkelhoff. It's a good way, like that's how I remember it. But there are many other ways that you could arrange the letters that make up the symbols of these gases. So, you could probably come up with plenty of variations on your own, maybe a word that would better stick in your head. So you can use Brinkelhoff, or you can come up with one on your own. Here's another way that you can remember them. Some people, instead of using the chemical symbols as letters, like to remember a phrase. And this one gets used a lot. People say, have no fear of ice cold beer. We want to talk about the letters that are in each of these words. So we have H for hydrogen, N for nitrogen, F for fluorine, O for oxygen, I for iodine. It gets a little bit tricky with these last two, which is actually why I prefer Brinkelhoff. But anyway, cold. Don't be confused and think that the C stands for carbon. It's Cl, chlorine, and then B, and the R at the end of beer. The R at the end of beer is bromine. So you can think of Brinkelhoff, or another way to arrange these guys to come up with a word, or have no fear of ice cold beer. Hey, you can probably also come up with another phrase yourself that you like even more than this. Okay? So that's how to remember them. Now, if you're interested, I'm going to take just a minute. I'm going to talk about why these diatomic elements actually pair up. Okay? Here's the reason why. The reason why is that on their own, the diatomic elements are sad atoms. They're unhappy atoms because none of them have a full valence shell of electrons. Here I've drawn electron dot diagrams of each one of the atoms. Remember that most atoms want to have 8 electrons in their outer, in their valence shell. None of these guys have 8. Hydrogen would be happy if it had 2, but it only has 1, so it's unhappy too. All of these want to increase the number of electrons that they have in their outer shell so they can have 8, or in hydrogen's case, so they can have 2. So here's how they do that. Let's take a look at chlorine here as an example. Chlorine on its own is unhappy. We've got 2 of them next to each other, and they say to each other, they say, hey, we each have 7, we each want 1 more, we each want to have 8. What if we took these 2 electrons that we have and we decided to share them? Then we'd each be sharing 2, and we'd have 8 total. That's exactly what happens. So we have now these 2 chlorines. I'm going to draw in black here most of the electrons. And then they take these 2 electrons here and they share them. I'm going to put the shared electrons in red. So the electrons that are in red, these 2, they now belong equally to both of the atoms. So now this atom has 8 and this atom has 8. Because they're sharing, they're both happy, and the 2 electrons that they're sharing, the pair of electrons, connects them together. It's as if they're holding hands. And we can symbolize this shared pair of electrons by a line that indicates that the 2 atoms are connected together. Just, as I said, just like they're holding hands, or like there's a stick connecting the 2 of them. So we put this line here, and that shows that they're sharing a pair of electrons and that they're connected together. So, individually, on their own, they're unhappy, so that's why we never find one of them. But if they connect together and form pairs of 2, then they both have 8 valence electrons, so they're happy. This isn't just chlorine, but the same thing happens, say, with oxygen. Each oxygen atom needs two additional electrons. It only has 6. So what these two oxygens can do is they can share 4 electrons between them. Then they both have 8, and each one of these shared pairs of electrons we can draw as a line connecting the 2 of them together. Or nitrogen, each nitrogen atom wants 3 electrons. So they can share 1, 2, 3 pairs of electrons between the 2 of them, and then each one of them have 8. And each one of these shared pairs of electrons we draw in with a line connecting them together. So That's why they connect up, because they're unhappy with unfull valence shells on their own. They pair up, and then they have 8. Okay, so that was the diatomic gases.